Hello. Welcome to another edition of the Urban Report. I'm Lee Bernick, Dean of the College of Urban Affairs and host of the show. Today we have a really exciting program. Probably the things that I like most about being a dean is working with the students and seeing what they're doing. And this time, in this edition, we're going to be talking to three different segments with students, and most of them are from the College of Engineering. Our first guest is from the College of Engineering, Russell McLellan, right? And you're a civil engineering major, is that?
That's correct.
Okay, and what year are you?
I'm a senior.
And what do you want to do as a civil engineer? What was your idea about this?
Well, eventually I want to go into structural engineering and go to grad school, get a graduate degree, and go out there and start designing tall buildings.
Designing tall buildings. And you wanted to do that, and you went through civil engineering as opposed to architecture.
Yeah, I'm also fascinated with math. I really like the the mathematical kind of problem-solving challenges that you have associated with structural engineering.
Okay, and you're planning on graduating this fall or in the spring?
In the spring.
In the spring. And where are you from? Well, I don't know if we.
I was born in Denver, but I was raised in Las Vegas. So.
Okay, all right, good. So. One of the reasons that we have you on is not just because you're an engineering student, but rather you're part of a team of students that are in what's called the Solar Decathalon. Can you talk a little bit about what that means, the Solar Decathalon? What is the Solar Decathalon?
It's actually an international competition hosted by the Department of Energy and NREL. And it took a lot of effort just to get into the competition. Only 20 teams qualify. And we were able to make it through the initial selection process. We've been trying to get in for a while now, and this was the first time we were finally able to get in.
So wait a minute, there are 20 teams from throughout the world?
Throughout the world.
Okay. Do you know where some of these other teams are from?
Yeah, there's a team from Czechoslovakia, a team from Canada, USC is in it, Stanford.
Okay. But so we've made it this year. This is a big deal, right? I mean, to be part of one of these 20 from the world that are participating in it, and we've made it now. Pretty elite company. That's
right. It was actually really difficult. Like I said, we've been trying for a long time. The competition is actually, we're building a full-scale house, and there's a lot of design challenges with the house. It has to be transportable. We build a permanent chassis and drive this house to the competition site, and then around on tours. We're actually going to start construction next spring, and so far we've completed the design phase of the process.
Okay, wait a minute now. Let's get this. You're designing a house. It has to be actually the real house, right? And you got to put it on a structure so that it can be almost a mobile home. Is that right?
That's correct.
But it's not the typical mobile home.
Oh, no, it's not. It's a manufactured house, so we build a permanent chassis to transport it. It's actually transporting sections as well, because we have other features that are going to be built onto the house on site. Okay.
And how big of a house is this?
Per competition rules, it has to be in between 750 and 1,000 square feet, so it's fairly small. Ours is 760 square feet.
Okay. And how many, does it have bedrooms, and you have to worry about all those kinds of things?
That's right. We have 2 main rooms, and one is a bedroom, but both rooms have multi-use roles for the house, and the architecture team did a really good job of, it's only 750 square feet, but it feels like a lot more, not only because of the mixed-use stuff that they have, but also there's a lot of built-on aspects of the house that surround the house.
Okay, and again, this is part of a Solar Decathalon. So what's the point? I mean, we're not just building the house. What are we trying to do with this? I mean, what's the criteria for being successful in this house?
Well, the competition is about showing the public how easy it is to implement certain energy saving or energy generating features in your house. So as part of that, the Solar Decathalon house is a net zero house, meaning that it doesn't require extra energy from the outside. It powers itself, and we power ourselves via photovoltaic panels on the roof. We also have energy for our solar thermal water heaters. So, and then we also have a lot of energy savings technologies implemented into the house to reduce our energy needs.
So, in theory, you could put this house on a lot and it wouldn't have to be connected to the grid. Is that right?
That's correct. A challenge associated with that is batteries. It's kind of tough to find a battery to really support you doing that. But in theory, yes, you can.
Okay, so when you get done building this, you have to take it somewhere. Where's the competition, the finals at?
The competition is going to be in Irvine, California, next October.
Next October. So will you be around for this? You're a senior, so you're not going to be around when they actually, is that right? Or are you planning on just hanging around afterwards anyway?
That's right. I'm going to be graduating, and I'm still not sure where I'm going to go, but I'm definitely going to make an effort to be out there. It's going to be a pretty big deal. A lot of the major schools around the country are going to be there. A lot of leaders in the industry are going to be out there.
Okay. Well, we have to stop here in a few seconds, but I want to thank you for coming in. I want to wish the team good luck, and hopefully we'll have you back and some other members of the team to talk about how the house is moving along here. And so I appreciate you coming in. Good luck on the project, and I hope we can say that we're winners of the Solar Decathlon.
Thanks for having me, and I really appreciate that. I think UNLV has a real shot at taking the first place this year.
Okay, let's take a break. Thank you.
For others, it may have just been a summer job. But for me, it was training. Now I'm an Air Force pararescueman, and my job is to save lives. Make the right choices today, and be ready for the challenges tomorrow. This message is brought to you by the U.S. Air Force.
Think you found every hazard out here today? Think again. The spot you missed could be a killer. That spot on your skin could be skin cancer. Fact is, if you're a man over 50, you're in a group most likely to develop skin cancer, including melanoma, the kind that kills one person every hour. 1 in 5 Americans is likely to develop a form of skin cancer during their lifetime. That's why your best shot is to check for a spot. It's easy. Follow through and check your skin. It could be the save of a lifetime. Go to spotskincancer.org to find out how. A message from the American Academy of Dermatology.
Winston, just one more inning, Grandma.
Ever notice how many things today kids can do without actually moving? A whole lot of things their parents used to do the hard way. So many kids' activities today seem to leave out the activity part, which makes exercise even more important for children. In fact, new research tells us the best time to enhance bone development is during childhood and adolescence. And just getting children to walk an extra 35 minutes a day could spare them the pain of thinning bones later in life. Healthy bones come from healthy habits. Encourage your kids to get up, get out, and get moving.
Hello.
Hey, Grandma, how about another grape soda?
A public service message on building strong bones for kids from the Pediatric Orthopedic Society of North America and the American Academy of Orthopedic Surgeons.
Hello, welcome back to this edition of the Urban Report. And as promised, we have another set of students who are from the engineering college, and they were part of the senior design competition. Is that correct? So to my right is Daniel Sigler. Is that right, Daniel? And over to my left we have Amber Sippen. Is it Amber Sippen? Is that
yeah.
Sippen? And Jinger Zeng, right? And you're all seniors. When do you plan on graduating?
In spring.
In the spring?
I graduate this semester.
You graduate this semester?
So in like less than a week.
Less than a week.
Spring.
In spring, okay. But you're part of a team, and this is part of the senior design, and the team actually has a fourth member. Who's the fourth member?
That's our machinist. His name is Tony Filipiak.
Oh, okay, Tony, and he is the one who actually put together is that what you're saying?
Yes, he's a machinist. He machined all the parts, fabricated everything.
So let's talk about your project. again, the senior design project is something that you had, the competition was when? When was the actual judging?
December 5th.
December 5th was the actual judging, and you were together and you came up, who came up with the idea? Did you all come up with this idea together, or?
I think it was kind of like a spontaneous thing because we were actually friends since we started going to school for engineering. You know, we met, we studied together, was in the student org together, and then we end up doing homebrew together. So
Wait a minute, stop here for a second. So you did homebrew, so you were making beer? This wasn't a class project, was this a class project?
we were making actually mead.
Okay.
And you know, also we did some beer.
Okay.
So,
And so you were doing this and you said what? We need to, your project is a bottle capper?
yes.
Is that right?
Yes.
And so you came up with this idea and you're all sitting around and said, oh, we need a bottle capper?
Yeah, so what happened is we make our, you know, beverages, and then we have to, you know, we usually make in a 5-gallon batch, and then we end up have to, you know, put it in bottles to store it, because we can't drink it all.
Well, I hope not.
And so what we used to have is like a manual hand crapper, and they always like breaks a bottle. So, you know, as engineers, as you know, we taking more classes, you know, we figure out there's a better way to do it. So we pretty much invented this machine to automate the process.
Okay, so Daniel, let me ask you, you're part of this thing. What was your role in this project, as it turns out?
So I did all of the automation and controls for the project, and I guess I was also responsible for coming up with the crazy ideas that we added to it.
The crazy ideas that you added to it.
Mm-hmm.
Well, let's just start with the basic idea. The basic idea is for you to have this in so that automatically will put a cap on a bottle.
That's right.
Right? What's the crazy idea?
Well, so we got our project done a little bit early, and we still had a little bit of free time left, so we started thinking about other stuff that we could do, and the first idea that we came up with was, you know, everybody's into social media nowadays, but when we're sitting around doing this stuff, we don't really want to be tweeting about what we're doing, so we decided to make the bottle capper itself actually do the tweeting for us. So every time it caps a bottle, it tweets it to the internet.
Wait a minute. How is it tweeted to the internet? What does it tweet to the internet, Daniel?
Well, it tweets the number of the bottle that it's capping, and there's a different phrase that it'll say for each bottle as it goes. And what you know, made it a little bit crazy and not just a neat thing is actually the more bottles it caps in a given batch, the drunker the tweets get that it posts.
This is way too strange on this thing. So
We tried for that.
Yeah, I can see that. This is what we would expect from engineering students, right? With a lot of time on their hand. So it essentially is like a cell phone tweeting out a message saying, okay, this is bottle number 5, and
Right,
and
so-
it has a phrase. By bottle number 15, the phrase sounds almost as if the machine was
It starts
drunk.
getting a little friendly with you. By the time you get to 40 or 50, because our batches are about 55 to 60 beers, yeah, it's pretty unintelligible, and it's like that drunk guy that you meet at
we
the bar.
Okay, and we don't let it drive. It doesn't drive
No.
anything.
That's an idea we're thinking about adding later.
That it can't drive if it's
Not
too
yet.
drunk.
No.
Okay, so Amber, let me ask you to talk about 2 things. One, I know it's in the front there. I saw some buttons. Can you explain what the buttons are for?
On the front end?
Yes.
Well, we have just an on and off switch, and when the system's on, you can hit the start button, and it basically just caps a bottle, as long as you put the bottle in the center.
In the center.
And then the top button is actually a don't panic button,
Right.
and if you hit that, the whole system stops, just in case you forget to put the bottle in, you know, you're too drunk or something. And
I see. So the don't panic is to remind you that if you forgot to put the bottle, you just
Yep.
stop.
You just hit it, and then you can twist it, and then it'll actually retract, and it'll go back to its beginning stage.
And what kind of caps? Are the caps metal pieces of metal that are already in the system, right?
You actually have to put the cap on yourself.
Oh, you have to put the
So-
cap on yourself,
Yep,
and
on
then
the
it
bottle.
it seals
Yep.
it, right? It's not creating the cap; it just seals the cap
Correct.
on the bottle.
Right.
Okay, and so it's being judged. The judges come to you all. And Amber, tell me what the judges said, or what questions did they ask you?
Well, they just asked basic questions like how does the electrical system work? Why did we add all the extra stuff? How does it work? What size motor we used? Stuff like that.
And they seemed interested in it?
Well, yeah.
Yeah or not?
They were kind of interested actually in the target market. They were asking about, because our target market is really like the homebrewing hobbyist who really are into do-it-yourself projects and putting stuff together like this. So they were interested in that kind of demographic, and we told them it's a really trending culture right now.
Okay.
Right. Initially, we made this for ourselves, but we never wanted to make this as a profit-generating device. So the whole project, everything that we've done with it, is being released open source under the Creative Commons license. So we want people to actually build one of these of their own.
Build one of these, and you're telling them how to do this.
Yep.
Well, this is fascinating. It's an example of how our engineering students are thinking creatively about things. I want to thank the three of you for coming in. We have to take a break. Good luck on the announcement that's sometime this week, right? Thursday or something, that you find out if you've won or not. Thank you. You'll have to demonstrate this. I'll have to come by and get a demonstration of this. So thank you for coming in. We've got to take another break.
If you could see anything in the world, what would it be? I'd love to see Paris.
I like to see cupcakes falling from the sky.
My daughter, married and happy.
I want to see things the way I used to.
Chances are, someone you love may one day be affected by macular degeneration or glaucoma. Log on to seeabettertomorrow.org or call 1-800-437-2423 to learn about glaucoma and macular degeneration. Call 1-800-437-2423 or log on to seeabettertomorrow.org.
I just want to see more of the things I love.
I remember the moment.
I'll never forget that moment.
That moment?
It was a moment that changed my life. I'd been training with my team for months, and now we had been called up for the first time. The real deal. Wildfires were getting dangerously close to homes. At that moment, I got my first taste of just how important the Guard is to my community.
See how the Guard can be an important part of your life at NationalGuard.com.
At what age is the color that your skin was meant to be no longer beautiful? Every year, millions of young women try to change the skin they were born with and say they die for darker skin. Sadly, some actually do. Melanoma is the second most common cancer in teens and young adults, and one person dies from melanoma every hour. Change your thinking, not your skin. Stop tanning. Learn more at spotskincancer.org. A message from the American Academy of Dermatology.
Something's not right.
My first symptoms were
constant tingling in my toes.
My legs, sometimes they'll go numb.
Double vision. They said you have multiple sclerosis.
Well, the beginning is the hardest time.
Kind of had to get a grasp on reality.
I had to adapt and change very rapidly.
I had to learn how to drive with my hands. Yeah, that was interesting.
I was a dancer. I don't see walking the way I walk any different than doing a dance. It just looks different. It's a different dance.
You see me have an off day, it doesn't take away from who I am.
A symptom may cause you not to be able to do that anymore. And at one point, I wasn't able to do any of those.
But I would exercise every day.
Since I've been cycling, it's definitely helped my walking.
To make a lot of changes in my life and just adapt to it.
I'm going to acknowledge its presence. I'm not going to discount it. But at the same time, I'm going to try my best to not let it stop me.
It's a fantastic opportunity to be working together with a common goal of curing MS, and sharing is the key.
Hello, welcome back to another edition of the Urban Report. In this segment, we have three more engineering students, and let me go through and introduce the three of you. It's David Fyda, is that right?
Yes.
Thank you, David. We'll come back and we'll talk some more. Ryan
Ghanaatrad,
okay, and Jorge Pulido, is that right?
Yes.
And you're all seniors?
Yes.
Yeah, okay. I should have known that because it's the senior design competition. You're part of a team for the senior design. Is there just the three of you in the senior?
Yeah, just the three of us.
Three of you. Okay, and David, you're from where?
I was born in Germany, but I was pretty much raised here.
Raised here. How about you?
I'm from Chico, California, but I've been here like 17, 18 years.
Oh, well then you're from here. All right, and Jorge, where are you from?
I'm from North Hollywood, California.
North Hollywood, California. And you came over here to go to school and go to the college?
No, I've been here like 17 years.
Well, you too. Well, 17 years is a long time in Las Vegas time.
Yeah.
Yeah. So, okay, you're part of the College of Engineering. Wait a minute. David, I forgot to ask you, what's your major in engineering?
Mechanical.
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 I should have known. You're all together on this team, so you didn't spread out and have one in electrical and one mechanical and one civil or something like that. You're all mechanical, huh? Okay. So you're part of the design competition. Is that right? Yep. The senior design competition. So let's start with this. David, tell me a little bit about the idea of coming up with this. How did you guys come up as a group, and what did you decide to do?
Well, the idea was to make a motorized TV wall mount. We got it from when Ryan was helping a friend move into his apartment. They had about like a 65-inch TV, and they were trying to mount it on the wall, and they kept having to like go back and readjust it. So then his friend said, wouldn't it be cool if we made it motorized, so that way we wouldn't have to keep doing this? And that's where we got the idea from.
Okay, wait a minute. So what are we motorizing?
The TV wall mount.
Okay, so tell me, when you say you're motorizing the TV wall, what is that? I mean, so it goes up and down or moves it a lot, so that you don't have to. Can you just put it on the wall and then it moves? Is that?
Yeah, you can put it on the wall flat, and then most of the ones out there right now are manually adjustable. So this one, it just works off a remote control, so it's pretty cool. You just hit a button and it'll push the TV out and rotate it if you go to like a different room.
Okay, so this is you've got to mount it. And then what you're saying is, if I sit in different seats, I can change the direction of the TV.
Exactly.
Right, of the monitor.
Yep.
Right. And so, what were the different roles that you all three played in creating this electrical or motorized? Excuse me.
Well, we started out with the drafting, where they worked out and they put it on paper after we did the mathematical calculations on a computer-aided design program. And then that was most of the first semester. And then we had to add the motor and the gears to it, was the second part in the physical construction. Then there was some electrical that we had to get involved in to build the circuit that drove the motors. And then there was some programming that we had to do to program the remote to work with the motors.
Okay, and Jorge, who did what on this thing? I mean, what was your primary job in this thing?
Well, we all pretty much worked together, so we all did most of the work together. So
well,
we all
I know,
build
but I mean, so you work together. When you say you work together, I mean,
well, we all based on what we worked in school, we all each of us did we would meet up Mondays and Tuesdays and work on it. And there wasn't one person that just did the circuits or something, or.
I mean, if we had to break it down, I would say a lot of the drafting and paper portion and machining was Jorge. And then the circuit and the programming, a lot of that was David, and then I helped out a lot with also the physical construction. So I would say electrical and programming and...
You're the electrical man.
Yeah.
Okay,
yeah.
And you're the design and the actual building this thing out. And where did you build this out at?
Machine shop. Now that was fun, yeah. Never had any machining experience before. And it was a lot of cool tools that we got to use. Most of it was done using a digital drill press, so you can get precision to within a width of paper.
So you were learning this, and this is all done inside the College of Engineering?
All from raw materials.
All from raw
nothing,
materials.
yeah. It was pretty
and
cool.
Who gave you the raw materials? Does the college has them?
We ordered parts from probably about 7 or 8 different companies, I think. Like the metals came from 2 different companies, and then,
But who had to pay for all this?
I got lucky.
Oh, I see.
I was the lucky one.
But you weren't given a budget or something like that?
The university reimburses you up to a certain amount.
Okay. All right. So then you get this. I have a couple things. Well, there's several questions, but one is, did you lose any monitors in testing this out that it fell apart or something like that? Did that ever happen?
No, that didn't happen.
It didn't happen?
No.
No? You were pretty sure it wasn't going to fall apart?
We used what they call a factor of safety, and we used a very high one. Typically with engineering, you want to use like maybe around 3 or 4, so you build it to be 3 or 4 times as strong as you want. Our advisor, I don't know if he wasn't confident in my math, but he made me use a factor of safety of 7. So you build it for like, say, 50 pounds, and technically it should hold 350, so.
Well, that's a good idea. I mean,
yeah, he's like, people like their TVs, Ryan, why don't you use a high factor of safety? And I'm like, and that's a good point, because this is done, it's used in a living room, so you don't want it to fall. There's pets, there's kids. You build something like that that's going to be around people, you want to make sure that it doesn't fail. The motor fails, that's one thing.
Yeah, but
the frame
all right,
needs
so Jorge, let me just ask you, we just have a few minutes left, or a minute left actually. What did the judges ask you? So the judges come and see this thing. You've actually got it somewhere on the wall and everything. What did they ask you?
They asked us like, where did we come up with the idea and the design, and where did we get the materials from, and.
Okay, and was there a sense that maybe this could actually be used somewhere? Are you guys planning on patenting this thing?
Yes.
Ryan emailed Chad Miller. He's one of the patents that UNLV works with, and we sent him the report, and he's going to get back to us on that. But we also had a different guy come approach us, and he was interested in our design, but what he wanted was an additional thing to move the TV up and down.
Oh, so you got to work on this. Well, I've got to come and we'll have to come back and see and talk to you some more about this and see about the patents. We've got to end this edition of the Urban Report. I want to thank you all for watching the Urban Report and seeing what kinds of fascinating things our senior engineering students are doing. They're doing a great job, innovation right here at UNLV. Thank you for watching the Urban Report.